So yeah, as I mentioned, we don't really have a volunteer presenter, so I'm going to improvise on this paper. And today we're going to talk about the functions as a service at Facebook and discuss their XFaaS system that they use at Meta. So the paper kind of starts and talks about, hey, we're big, right? So Facebook is big, and they happen to use a lot of like functions as a service in their private cloud, right? So they talk about having their like big data centers, tens of these data centers, millions of computers, and they run the function as a service platform that they developed in the house to host some of the workloads. So like of the interesting thing is they talk about using more than 100,000 servers to host their function as a service platform, which is quite a scale, I think. So what's I think important like is they outline some problems, right? So and a lot of these problems come from the fact that there is a discrepancy between like the demand at the peak and the demand off-peak hours, right? So if you want to run a function as a service platform, you need to be able to provide the peak demand, right? And they quote something like the difference of 2x between the peak demand and the off-peak hours at like cloud function as service offerings, and they say that at Facebook, like in their system, it's actually even bigger, right? So they have like 4 times the difference between the peak demand and off-peak hours. And if they provision for the peak demand, that's like a lot of wasted resources. So a lot of their motivation is like, how can they provision the system in such a way that how can they manage the system in such a way that they don't like spend too much resources on provisioning for the peak, right? And they also talk about common steps a function kind of needs to take, right? So there is like a big initialization phase where you start the VM, fetch the container image, initialize the container, start the language runtime, load libraries, do a bunch of things. Somehow they include the just-in-time compilation here, not in a runtime, but okay. And there is a shutdown phase, like what happens if the function is not used too often, right? So if the function is not invoked, we need to clean up resources, and again, that takes some resources to clean up the resources, right? And they say that only this part, right? So number 8, invocation, is the billable time. So this is what users run. This is what cloud vendors will charge for, and not like all of this stuff. So steps 1 through 7 and 9, 10, we want to like minimize them or avoid them as much as possible, right? So now, of course, Facebook is not a cloud provider in a sense that it doesn't offer their function as a service system to like outside clients, right? So even though like in the paper they talk about billable time here in the motivation, they don't really have that. They just want to make sure that they don't waste the resources and can run their function as a service at like high utilization and still meet like all of the SLAs that they give to the internal users, right? So and they talk about some of the challenges or risks, right? So they talk about the lengthy cold start time, which is kind of your standard problem for function as a service, which dominates by these 7 steps. The variance of load, right? So as I mentioned, they talk about like a 4.3 times the difference between the peak load and off-peak hours. They also talk about this like interesting problem, overloading the downstream services, right? And this actually, like their example reminds me of like metastable type of failure, right? So they overload some other component like a database or some kind of stateful system, and that starts to behave badly, time out. There are retries come in, and things start to fall apart. So they also want to make sure that their cloud, that their like function as a service system has some kinds of safeguards from overloads in the outside services to kind of avoid those perpetual loop failures. And yeah, so they outlined yeah, so yeah, let's I guess move on to yeah, some interesting like other things. They talk about the rapid growth of function as a service in their cloud, right? So that's kind of interesting. They showed the graph of like the adoption of serverless functions in their private cloud, and there is like something happened here. I don't know who they hired or whatnot, but I guess in 2023 that adoption like really like increased by a lot, and the rate of adoption increased by a lot. So something big definitely happened there. And yeah, maybe. It's not the workloads that they specify, right? So that's kind of what I want to talk next, right? So they also talk about the fact that they have different data centers, right? So, and they actually trying to build the function as a service system that is cross data center, right? So it's not like isolated to each data center or even each region. It's like cross data center and cross region. So if they need to load balance things across regions, they build the mechanisms to do this kind of on the fly. So that was kind of cool. And like one of the motivation for some capacity, some regions may have like more capacity because they've been like longer. Some regions maybe going through upgrades, so they don't have as much capacity. So the capacity in regions varies, and they want to be able to like balance the function invocation across regions as well. So in their system, it's quite possible that if some function is invoked in one region, it may actually run in another region if load balancing needs dictate that. So it's also interesting to see what kinds of workloads they have, right? So as I mentioned, like they are not public cloud. They don't provide that system to external users, right? So they actually have a very small, relatively speaking, set of unique functions, right? So they say that there was like over 1 month 18,377 unique functions, right? So those are not function calls, they're just like different code, right? So 18,377 different functions that exist in their system, right? So it's not a large number. Now let's move on to actually talking about like what these are, right? So they kind of break down some like invocations, some functions by different categories. So some are triggered by the queue. So 89% of functions, the queue triggered, but it's only 15% of function calls, but 86% of like CPU usage. So that's where they spend a lot of resources. They have event functions, like an event come in, like login and whatnot. It's a lot of function calls, but not a lot of like resources usage. And then there are timer triggered functions, something that they want to repeat like on a specific like schedule. Like what are the examples of this, right? So I found this like some parts of this are very interesting. So they talk about the typical benefits of serverless functions is like pay-as-you-go, no upfront capacity planning, and streamlined deployment or deployment only, like where you only write code. And they say that, number two is not a problem at Facebook. They have a very sophisticated deployment tool. So even without the serverless, that's kind of how the deployment works. The developers write the code and the deployment system takes care of the rest, right? So number two is not like a reason to use the function. And obviously pay-as-you-go, it's all internal, right? So they have kind of different motivation here. What happens is they actually never, or they seldom, handle interactive requests, right? So they don't use the serverless functions to actually like do stuff to, let's say, render a page or show something in the app, right? So they avoid running any code that's latency sensitive in their serverless environment, in their like serverless functions. So it's not like an immediate like user-facing code. So what are the examples of this then?
Wait, Alexei, you broke. Alexei, you broke up and I missed it. If those two are not the motivation for them using function as a service, what is their motivation?
Just ease of management.
Ease of management.
Their use case avoids doing the user-facing interactions, right? So they don't do anything latency sensitive on their serverless platform, right? So their serverless platform is kind of more like, hey, I want to run something that is not as latency sensitive, right? So they use it for like logging or for recomputing certain things that kind of happen in the background, right? And actually, some of the things that they like use it for, have a deadline of like 24 hours. So you can submit a function. You can tell, hey, run my code, right? Run this function, and it may run it anywhere within the 24 hours. So like a lot of the like workloads that they run on this are not latency sensitive at all. They just use it as like, a compute where you can throw stuff in and it will just get done at some point, right? But like nothing like latency sensitive. They don't run any of their like social graph on this, any of the like APIs, or anything that is required for like rendering the pages or displaying the apps or whatnot, right? So it's like mostly for the background stuff that just throw in the system and it will get done like eventually. So the like concrete use cases, I think, they mentioned the concrete use cases, a few of them here. So recommendation system, right? So if you like
We lost you for a second.
Okay, so I was going over a few like examples, right? So I was talking about recommendation system, how it's not like a latency critical stuff, your portion of the social graph updates, you add friends and whatnot, your recommendations will need to change, but it doesn't have to happen immediately, right? So they can just like schedule something to be recomputed and kind of forget about it until it's recomputed. Their login platform for like all kinds of logging all kinds of parameters, right? So these are the events, like something happens, they log it. Again, something that is like off critical path, right? productivity bot. So this is like the internal tools. Again, notification system, right? So they need to send you some notification or phone or whatnot. Again, this is usually not like super latency sensitive, right? If your notification arrives a few seconds later or a minute later, it's not a big deal. And then, yeah, so they also talk about this quite a lot. Morphine framework, a platform that programmatically generates ephemeral functions for executing custom data transformations across data stores. And not a lot of detail, but they keep saying this, keep repeating that this guy like is very heavy. It consumes a lot of resources, right? So, but again, this is something that happens like off the critical path of any user interaction. So then they talk about the resource usage. I think for the sake of time, I'll skip it. Aside from the fact that saying that this is where a lot of resources are being used. There is some interesting statistics about like how long the functions run and things like that. But yeah, and let's I guess talk about an actual like system, right? How it's designed and what it tries to do. So as I mentioned, it's spread across multiple regions, right? So it tries to balance the workload across multiple regions. So you have clients or events or something else submit the function call. So something in the system is asking for a function to run, and those clients, let's say, they will talk to the submitter. Right, so submitter should like check in. I keep breaking up, right?
Yeah.
Okay, 1 sec. So I was saying that clients can submit the functions. They submit it to a component called the submitter, and the submitter enforces things like checks on like rate limiting and things like that. And submitter is a stateless component, so if they need more submitters, they can just create more of them, and yeah, that's it. The submitter, when it receives the request, it places the request in QLB, which is essentially like a load balancer, the first load balancer that they have. It sits in a queue, and as it gets out of this queue, this is the first place where we can attempt cross-region loss balance, right? So it goes into a durable queue. So these are like in each region, right? So this is where you can decide, hey, do I stay in this region or do I go to like a queue in another region based on like load balancing needs and whatnot. So this queue, durable queue, is where your like request, your call is going to be, kind of persisted until it's executed, right? So, and from that queue is going to be picked up by a scheduler. And the scheduler has a function buffer like for each function, so it picks up stuff from a queue, says, oh, this is a function of type whatever, a function A. I have a buffer for function A, and most of the job of the scheduler is just to place it is to order those functions. Is to say, hey, I'm going to run, like out of all the function buffers I have, I'm going to run these functions in this order, right? And it places them in the run queue. So this run queue kind of enforces the order. Oh yeah, and I forgot to mention that here we can kind of cross-region load balance again. But yeah, run queue places an order, and then we go into the worker load balancer. I'm not sure why it's not part of the scheduler, because the worker load balancer is actually something that takes stuff from this queue, says, okay, I dequeued a job, I need to place it in an actual worker, and we'll find the worker that is like a compatible worker for this particular job. So I'm not sure why this worker load balancer is not really part of the scheduler bugs, because this is the component that actually like decides the actual worker that's going to run the job. And yeah, they have like worker pools, and yeah, they also have a few global components, right? So there is a global configuration manager, the rate limiter, traffic conductor, locality optimizer, and yeah. So I think I want to talk a little bit about the rate limiter and the traffic conductor. So one of the like features that they have, right, is one of the features that they have is they can postpone execution of some jobs, right? So each job, each function call has a priority, and it also has like a deadline, right? So remember how I mentioned that they're not using this for critical stuff. So the deadline of a function is like, hey, when do we need this function, to start executing really? So when the scheduler picks up the function from durable queue actually orders them by the deadline, right? So the ordered by the deadline. So we only schedule, like we only work with the functions that we want to run like soon. And the central like rate limiter, it will like also says, hey, does the system approach the capacity? And if the system is approaching the capacity, then you can start slipping the deadlines of functions that don't require very like tight latency, right? So none of them really require super tight latency, but some functions, for example, require, they mentioned 15 seconds or so latency, right? And some are okay with 24 hours. So, they can start like playing with those functions and saying, okay, I'm at capacity, but this function, can wait for up to 24 hours. So it's not going to be executed now because the resources are more important for the functions with tighter deadlines, right? So based on the input from the central like rate limiter, there is going to be like a rearrangement of jobs, and that's why this guy, the order is important. Like the main job of the scheduler is to figure out what job to run next based on its priority and the deadline. Yeah, so they talk about like each component in more detail. There are a few like other interesting things. Like they try to avoid the so the workers are interesting somewhat. Like in the workers, they do things that I think are possible only because of the fact that they're not like public product, right? So they say we want to have a worker, like a universal worker, right? And what they mean by universal worker is like any worker, if it needs to, can run like any function. And it's not really how it works. So they still like divide the workers into namespaces. So they have like 20 or something namespaces. So it actually like a worker from a namespace should be able to run any job from that namespace. And they further subdivide it down into locality group. But the point is like the workers in those namespaces, they actually have the code sitting on SSD for like all the functions that that namespace can run, right? So if the need arises to like run a new function, it can just like it doesn't need to download it anywhere. It doesn't need to start it up. The code is already there, and it can just run that code in a process that's kind of already spinning, right? So it doesn't create the containers or anything. It just like runs a function in a thread of some process. So like that's how they avoid like a lot of the cold start issues. But a lot of that is possible because it's all internal, right? So they write code that they trust, and they don't have like that many functions, so they can like kind of pre-cache everything. And on top of pre-caching the functions, they also have cooperative just-in-time compilation. So as some function changed, it starts running in some workers. They will do the just-in-time compilation, and they will share that information with other workers, right? So that when the next worker needs to run that same function, it doesn't need to like start from scratch in a cold start. And yeah. I think we covered a paper that specifically talks about this feature from like some other team before. And yeah, so the big deal for them is handling the load spikes, because that's how they make their system efficient, right? As I mentioned, this is where that central rate limiter comes in. It decides whether to throttle the invocation of a function based on whether the function, globally exceeds its, limit. The limit is a dynamic limit, so like they adjust like how much each function can run based on like the current capacity, and they have something called time shifting computing, and that's when they decide, hey, I cannot run this function right now, but I can postpone it until the off-peak hours and run it later. So they schedule some functions to run like way like into the future, like up to 24 hours. Yeah, and they also talk about how they implement like the overload protection for downstream services with the additive increment, multiplicative decrement, decrease approach. So they kind of re-implement the TCP parts a little bit here, but they just try to again like avoid scheduling, avoid running things that will overload a particular server if a particular service, if that service starts to show the signs of being overloaded, right? So if particular function is going to target a service, and that service happens to be overloaded and slow, then the scheduling is going to start kind of slip up. So the serverless platform is going to start delaying more function calls for that service, so that touch that service. Okay, I think I've been talking too much at this point. The big thing that they brag about is roughly 66% CPU utilization in their serverless platform, which they claim anecdotally is like twice as much as the public cloud functions achieve. So that's one thing that they like really brag about in a paper. They also brag about their like a cooperative just-in-time compilation, how it kind of improves the throughput, right? So with the cooperative just-in-time compilation, you can ramp up the throughput quickly, but without it, every worker needs to like do